Hello and welcome to our first ever video lecture, and the topic that we have chosen is stacks using linked list. I am Nisha Balani from First Impression Technologies. So before we proceed with the topic stacks using linked list, let us first understand what are stacks and what are linked list. So both stacks and linked list are nothing but data structures where we can store elements. Let us begin with stacks. So this is a kind of representation of stacks. Here, inserting an element into the stack is called as push operation, and deleting an element from the stack is called as pop operation. There is a pointer called as top. Initially, when there are no elements into the stack, the top will point to null. As soon as we insert first element into the stack, see here in the diagram we are inserting 2, or I can say push 2 into the stack, the top pointer will be pointing to the topmost element, which is 2 in this case. Then again I am pushing another value 5 into the stack, so 5 becomes the topmost element, thus top pointer is pointing to 5. Similarly, in the next case, top pointer is pointing to 7 and 9. Okay. Stacks performs deletion in the form of last in, first out. Here the element 9 is inserted at the end, so this element will be the first one to be deleted from the stack. Okay, so as soon as we start deletion of elements from the stack, 9 will be deleted and top will be pointing to 7, which becomes now the topmost element. During the next deletion phase, 7 will be deleted and 5 becomes the topmost element. Similarly, now 2 becomes the topmost element, thus top will be pointing to 2. As soon as we delete 2 or we delete the last element of the stack, top will again be pointing to null. So this is a representation of stacks. Very simple, very easy to understand. You all might be knowing this before. Let us understand what are linked list. Linked list is nothing but links of data. That is why it is called as linked list. Here there is a node. So this portion where we have two fields, one is called as data and another is called as link. This particular portion is called as a node. A node contains two fields. One is called as a data, with a value that we have to insert into the linked list, and another is called as a link field, which is address of the next node. See here the next node. This is the next node and address to the next node is 100, and this is saved in the link field of previous node. Right. Okay, now if I want to insert next value, say 30, so 30 will be added in the data part of the node, and link part of the node will contain address of the next node. Here we maintain basically two pointers. One is called as first, which will be pointing to the first node, and another is called as last, which will be pointing to the last node in the linked list. Since this is the last node and we do not have any other nodes in the linked list, thus link field of last node will always contain pointer null. So let us begin with our topic, stacks using linked list. So stack is a data structure that stores data in the form of last in, first out, that we have already seen. So this is a property of the stack, and we will maintain this property even if we are using, even if we are denoting stacks using linked list. Okay, here also we will be maintaining a pointer called as top, which is a pointer of the stack. Let us understand the basic concept using diagrammatic representation. So here we have this diagrammatic representation of insertion operation, or we call it as push operation of the stacks using linked list. So we are considering here two cases. One case is if we do not have any element in the stack, that is we are inserting the first element into the stack, then the node will contain your first value. In this case it is 10, and the link field will contain null because this is the first node that we are creating. The top pointer will be pointing to this node, the top node, right? Consider the case 2 where we already have few elements, say 10, 30, 50. The top pointer will be pointing to the topmost element. Here in this case it is 50, right? The link field of the topmost element will contain null because there is no next node. I hope this is clear already. Now suppose that we want to insert a new node, and the new value that we have to insert is 90. So what changes do we have to do in this diagrammatic representation? Number one, the link field, since the new node will be the topmost node now, the link field of this new node will be null. And the link field of the previous node, which was previously top node, the link field of this node will contain address of this new node, right? I hope this is clear. So let us write function of the same using these two cases. So this is the function for insertion in the stacks using linked list. We call that function as push operation. Okay. Initially the case 1 where top is null, where we do not have any elements, this was our case 1, right? This is the case 1. Okay. So we will be allocating a memory during runtime to the top node. Okay. The data field of the top node, that is top pointer data, will be the value that you have to store, and the link field of the top node will contain null. Very simple, very easy. Now if we already have few elements, that was our case 2, if we already have few elements 10, 30 and 50 like this, then what will happen is we have to create a memory for the new node that we have to insert the runtime memory using malloc function. The data field of the new node will contain the value that we have to insert, and the link field of the new node will contain null, right? That we have already seen here. See, new node, the value will contain 90 and the link field will contain null, correct? Now what happens is the link field of the previous top node, जो अभी आपका top node है, the link field of that top node will contain the address of the new node, that is new, and now the top will point to the new node. I hope this is clear, and it is very simple if we understand using diagrammatic representation. And if we have to count the number of nodes, we can maintain a counter called as count, and we can increment as soon as we insert any node into the stack, right? Similarly, we can display all the elements in the stack. To display all the elements, what we are doing is we are creating a new pointer called as top1, which will be pointing to the first node. And if we do not have any first node, or if we do not have any node where top1 is pointing initially, if it is null, then the stack is empty, obviously. If the top1 is not equal to null, means if we have few nodes in the stack or in the linked list, then what we will be doing is we are printing the data field of the top node, right? And we are incrementing the top value using the pointer top1 is equals to top1 pointer link till it becomes null. I hope this is clear. It is again okay. Now let us understand the deletion portion, or we can say pop operation of stacks using linked list. Okay, as we already know that the element to be deleted will always be the topmost element of the stack, or we can say where the top pointer is pointing, that element will be deleted. No other element can be deleted from the stack. Here the element that will be deleted from the stack is element 90, where the top is pointing. Now to delete this element, we have to do few changes in the linked list. What are those changes? We have to delete this element where the value top is pointing, and we have to make top point to the previous node, number 2, and number 3, we have to make the address of this node, the previous node, as null, because there won't be any other element at the end. These 3 steps we have to perform using deletion. Okay, so what we will be doing is we will be maintaining one pointer called as top1, which will be pointing to the first node of the stack. Okay, now we will start incrementing this pointer to reach to the previous node of the top, that is here in this case where the value is 50. Okay, so what we will be doing here is we will be incrementing top1 pointer. To increment top1 pointer, we have to make that pointer point to the link field. See, now we have to make top1 pointer, which is presently pointing to 10, to point to 30. Okay, that is called as incrementation. So we have to make that pointer move to the link field. Here the link field is 100, so this will be pointing to 100. See, right? Again, we have to make that pointer point to the link field of the next node, 200, till it reaches to the link field of the top node. Okay, so that becomes the previous node of the top. Now we won't increment this pointer because it reaches the link field of top 1 now contains top. Okay, so this is the criteria. So let us see the program part of this deletion portion. Okay, here it is called as pop operation. The first portion, case 1, remains the same. If top is pointing to null, there are no elements to be deleted. We can simply print that empty stack. Otherwise, what we will be doing is we will maintain a pointer called as top1, which points to the first node. Then we will start incrementing top1 pointer till it reaches to the top. Then we will increment top1 is equals to top1 pointer link till it reaches to the link of the top field. Right, now we can delete. What we will be doing is deleted value is top pointer data, that is, in our case it is top pointer data is 90. And what we will be doing now here is we will make top point to top 1, right? Top point to top 1. I hope this is clear. For more videos or for more such things, you can follow us on Instagram as First Impression Technologies. Do let us know more topics for which you need video lectures by us. Thank you. We also have few internship programs at our company. These are the courses. Come and learn with us, work with us, and create a new era of coding. Thank you.